Hi, and welcome back to Module 6, which is on logical storage and storage virtual machines. After physical storage, you would think we'd be talking about logical storage only, but you cannot have data volumes without having SVMs. As a matter of fact, you cannot have any volumes without having SVMs. So we have to talk about storage virtual machines as well. First of all, let's have a look at the different types of volumes that we have. To start with, we have vol 0. Every node, as you remember from the overview, has vol 0. And the purpose of that volume is cluster configuration and some other stuff. Also, your SVM that holds vol 0 is the node SVM. So every node has its own SVM, and that SVM has only got one volume, which is never a data volume, and that's vol 0. That does not contain any user data, only cluster metadata. Now, when you look at that, what you see here is that the metadata consists of replicated databases, which we will talk about later, log files, which we will also look at later, and configuration backups, which we will also look at later. So in a sense, your vol 0 never contains user data. And of course, the size of such a volume is controller dependent. The larger the controller, the bigger the volume. Then we have something which is called root vol. It's very often confused with vol 0, but you should definitely make a distinction between these two, because the root volume is the starting point of the storage virtual machine where it concerns the data. So your root volume, every SVM has a root volume, which is a very small volume of 1 gigabyte to start with, and it doesn't contain any data either. It only contains junction paths. So there's no user data in root volume of a storage virtual machine. And the root volume is a volume of an SVM, and that is always a data SVM. So it's not part of the node SVM, it's part of a data SVM. And the purpose is to give access to the namespace for NAS clients. Then, of course, what it's all about is about data volumes. So your clients want to store data in your ONTAP environment. They need data volumes. And the purpose, obviously, would be client data, and it would be part of a data SVM, and it would contain user data, and the size is a minimum of 20 megabytes. So you can grow your volume for as large as the aggregate, but the minimum size is 20 megabytes. Finally, we've got something which is called a data protection volume, and that data protection volume is used for snap mirror, is part of a data SVM. It does contain user data, but it's read-only for as long as it functions as a destination, and the size is minimally the same as the source. We'll talk about data protection later. Now, when you talk about data volumes, you have two types. In fact, you can have stored two types of data. First of all, you can have file level access, which is important to know for the exam. So NAS clients have file level access. When we talk about NAS and SAN, we'll dig this out a lot deeper. But you can have files in a NAS volume. Next to that, you can have SCSI blocks, SCSI data, in a SAN environment. That means you would create a LUN inside a volume. You present the LUN to a client. The client will partition the LUN and put SCSI data on it. So, for example, this could contain an NTFS file system or an X2 file system or X4 if you have Linux. So there's two different types of data in these volumes. You could mix that if you like, but that's not best practice. Then also very important to know is that an SVM has something which is called a namespace. If you want to store data in your storage virtual machine, you need a namespace. And the namespace is always starting with the root volume, which contains the junction paths for the volumes that contain the user data. You see a data protection volume in here, so your storage virtual machine can also host data protection volumes. As I said before, you cannot have logical volumes for data or for configuration without them being part of a storage virtual machine. And another thing to notice is that such a volume may be in any aggregate on any node. So you can have 6 nodes, and these volumes over here could be spread out across all of these nodes. They don't have to be part of one single node or one single aggregate. Then we have a number of types of SVMs. First, of course, we've got the data SVMs. That is where we store our data. You can have multiple data SVMs in your cluster. Again, realize they are not bound to a node. Then we have a system SVM, which is definitely bound to a node, as is a node SVM. The node SVM contains vol0, that's the purpose of the node SVM. The system SVM is for your cluster interconnect. So we'll look at that later. And of course, we have something which is called the admin SVM. And the administrative SVM is a management SVM for your cluster. This is the one you will connect to when you access your cluster as the admin user or as any other user that wants to administer the cluster. So to wrap it up, your node SVM is one per node, and vol0 is the only volume. Your admin SVM is one per cluster, and it's there to administer the cluster, so access the cluster shell. Then we have the data SVMs, that's for storage to clients, and we've got the system SVM, which is there for the cluster interconnect.